Hello my dear students, welcome to the class of 12th English medium. The subject is statistics, part 2, chapter 4, limit, presented to you by Vitan sir. This time we will be solving sums based on the second form of limit equations. Now in the initial stage I explained you there are two forms for solving limit. The first one was the polynomial form. The second form is this: limit x tends to a, x raised to n minus a raised to n divided by x minus a. When this kind of form is available, we directly solve it as n into a raised to n minus 1. Now let us understand this in detail through some illustrations. Illustration number 25, we have to find the value of limit x tends to 2, x raised to 5 minus 32 divided by x minus 2. Now first we just write it down as it is. In front of this we will copy down that format so we can have a reference of it whenever we are solving this sum. Now as you can see here, x raised to n minus a raised to n, while our question is x raised to 5 minus 32. So what we are going to do, we are going to convert this 32 into 2 raised to 5. Now where do we get this 2? So we just see that x tends to 2, so 2 is of essential here. So whenever we are creating powers, we will create that power depending on the value to the limit. So we are converting our equation here to x raised to 5 minus 2 raised to 5 divided by x minus 2. Now this equation and the form both are very similar, so we will directly write it down. The n value in this question is 5, the a value in this question is 2. So we are going to write it down as 5 multiplied by 2 raised to 5 minus 1. So in each question you have to decide what is the n value and what is the a value. Now 2 raised to 5 minus 1, first solve the power then multiply. If you multiply first you will make a mistake. So first solve the power. 5 minus 1 makes it 4. So 2 raised to 4 is 16 and 16 5s are 80. So your answer for this equation is 80. So the limiting value for this limit x tends to 2, x raised to 5 minus 32 upon x minus 2 is 80. Let us take one more sum to understand it better. Illustration 26, here limit x tends to 3, x raised to 5 minus 243 divided by x raised to 3 minus 27 is given. Let us write down the question first, then we will see what we can do about this. Now as you can see, first we have to convert it into powers. The x tends to 3, so the power should be on the value 3. 243 is 3 raised to 5, while 27 is the 3 raised to 3. So we get x raised to 5 minus 3 raised to 5 divided by x raised to 3 minus 3 raised to 3. As you can see, our format here is x raised to n minus a raised to n upon x minus a. That just means that in the division we need x minus 3, but we don't have x minus 3 in the division. Rather we have a powered value, that is x cube minus 3 cube in the division. So what we are going to do, we are going to create a value on our own from the given question. So this x minus 3 upon x minus 3 is an additional value which I have added in this equation. What I am going to do next is I am going to replace this x cube minus 3 cube with x minus 3. So that way I will get something like this: x raised to 5 minus 3 raised to 5 upon x minus 3. So this first part is complete. This first part is according to our form. But this second part seems a little bit off, as our numerator should be in the denominator while our denominator should be in the numerator. So that we will do in the next step. We will be inverting our equation, but when we invert it, this multiplication becomes division. So now this is the ready format according to our second form of limit. First is x raised to 5 minus 3 raised to 5 upon x minus 3, and second is x raised to 3 minus 3 raised to 3 upon x minus 3. So right now we have two forms which we need to simplify. So for the first form, the value of n is pi, a is 3. For the second form, value of n is 3, a is 3. So accordingly we are going to write it down As you can see, I have written down the form here which we have to write for the sake of explanation. So it will look like this. For the first form, 5 into 3 raised to 5 minus 1. For the second form, 3 into 3 raised to 3 minus 1. For the first form, n is 5. For the second form, n is 3. After the subtraction of the powers, we will get 5 into 3 raised to 4 divided by 3 into 3 raised to 2. We will solve the powers first. So we will get answer like 5 into 81 divided by 3 into 9. After multiplication, we will get 405 divided by 27, and your answer is 15. So whenever the values are there in powers in both numerator and denominator, you have to add an additional value here. So that way you can make two forms out of a single equation. Next is illustration 27. Now in this question, as you can see, the limit is negative 2 and our equation has plus signs in the numerator and denominator. So first we will write down the equation as it is, and then we will write down the form so that we can compare it effectively. In the form, our sign between the equation is negative, minus sign, while in the question the signs are positive. That is due to our limiting value. The limiting value itself is a negative 2, so negative negative makes it positive. So to again convert it into our original format, we will put two negatives with negative 2 sign in the bracket, and as we know, our negative 2 should be in the power. So right now the power of x is 7, so negative 2 with the power 7 makes it negative 128, and that negative 128 with negative sign makes it positive. So that is the reason why these values are in positive, as two negatives are there. Once we get this value according to our format, we just have to simplify it using the ready-made answer. The value of n here is 7 and a here is negative 2. We just have to put that into our equation here. So n is 7, a is negative 2, and in the power 7 minus 1. 7 minus 1 makes it 6. Now remember, when negative value has odd powers, they remain negative. But when negative values have even power like 2, 4, 6, they become positive. So negative 2 raised to 6 makes it 64, multiplied by 7, your answer is 448. So this is the limiting value for this equation. As you know, whenever our question given has positive values in between, but always remember that our form must be a negative. So the limit must be negative also. So that way you have to convert it into double negatives. So that way you can simplify it properly. Don't get confused with these positive values. Let us take a somewhat different sum here. The form will be same, the method will be same, but we have to suppose here. Why? Because as you can see, our format does not contain plus values like this. Here x plus h whole raised to 5 is given, while we only need a single value to simplify it. If we have double value like x plus h here, we can't solve it. So what we are going to do, we are going to start with suppose. Yes, supposing, assuming is what we can do in statistics everywhere. We will assume x plus h as t, and when we change the side of x, it becomes h is equal to t minus x. As you know, in the division we only have h, but in that place we need to put two values. So in the x plus h, I will replace it with t, while the division h, I will replace it with t minus x. But when we assume x plus h as t, and we know that h is 0, h tends to 0, so we can assume h as 0. So when h is 0, then t is x. So when h is 0, t becomes x. So this is what we need to remember, and this t, t minus x, and t tends to x, these three values I will put into my equation here. This is the original equation, and I will be replacing it with the assumed values. So see, the limit changes to t tends to x, x plus h changes to t, and h changes to t minus x. Now this looks more like our original format. So what we need to do, the n is 5 and a is x. Remember, n is 5 and a is x. So According to our formula n raised to n minus 1, 5 into x raised to 5 minus 1, the answer will be 5x raised to 4. Yes, it's not necessary that each and every time you get a specific value. You can also get answers like this in this type of equations. Let us complete today's tutorial with a last question. Actually, this is the last illustration of the chapter. With this, our chapter will be over. But in the next tutorials, I will be solving some sums from the final exercise. Let us complete this sum here. This sum has a square root value, but even if this sum has a square root value, it is not actually a square root, it's nth root. So we can't use that method which I taught you for solving square roots, as this is not a square root, this is an nth root. So when this kind of questions are there, we have to follow that second format which we are discussing right now. First of all, I will be converting this nth root into the power. When I convert it into power, it becomes 1 upon n in the power. Whenever we are having root values, and we want to convert it into powers, it will be written in the division of the power. So if it's a square root, it is 1 upon 2 in the power. When it is cube root, it is 1 upon 3 in the power. And if it is nth root, it is 1 upon n in the power. Now 1 is a value which we can take as any power or any roots. So it was just a simple one, but I have converted into 1 raised to 1 upon n, so that I can have uniformity in the both values. Now this is the question where again I will have to suppose, because you know the format is x raised to n minus a raised to n, and I have x plus 1 here. So what I'm going to do, I'm going to suppose that x plus 1 is t, and when I change the side of 1 here, because you know the division is x, so I will keep x as it is. I will change the side of 1, so that way x will be t minus 1. So in the numerator x plus 1 I will write t, and in the denominator x I will write t minus 1. Now here x tends to 0, x tends to 0. So if I take x as 0, t will be 1. So when x tends to 0, t tends to 1. So x plus 1 is equal to t, x is equal to t minus 1, and t tends to 0. These are the t tends to 1. These are the three values which I am going to put into my equation. It will be limit t tends to 1, t raised to 1 upon n minus 1 raised to 1 upon n divided by t minus 1. So now this equation looks a lot similar to our second form. Here the value of n is actually 1 upon n, the value of a is 1. So this I have to put into the format, and I will get something like this: 1 upon n into 1 raised to 1 upon n minus 1. Now if you are wondering what to get 1 upon n minus 1, actually it doesn't matter. 1 raised to anything is just 1. So we just write 1 upon n into 1, and your answer here will be just 1 upon n. So the limiting value for the equation here is 1 upon n. And with this we end all the illustrations for this chapter. What we are going to do next time is we will solve some selected sums. I mean, I am not going to solve all the sums of the final exercise, but I will be solving some landmark sums which actually define the method of other sums for this chapter. So that way you can get a guidance how to solve remaining sums which I will be leaving on you guys. Till then, stay tuned and see you soon.